Have you ever looked closely at a massive modern ship resting in a dry dock? If you look right at the very front, just below where the waterline would be, you'll notice something strange. It's a gigantic, protruding metal lump. It looks like a weird, swollen underwater nose. And to be honest, it completely ruins the sleek, sharp lines of the ship. Common sense tells us that pushing a giant, blunt object through the ocean would create drag and slow a ship down. But in reality, this bizarre protrusion is one of the most important engineering marvels in modern history. Without it, global trade as we know it would be impossibly expensive. Welcome to Simple Things Surprising Histories. Today, we are uncovering a multi-million-dollar secret of the sea and answering the question, why does every modern ship have a weird underwater nose? To understand why this giant nose exists, we first need to understand the invisible enemy every single ship faces: drag. When a massive vessel plows through the ocean, it has to push thousands of tons of water out of its way. This aggressive action creates a huge rolling wave at the front of the ship, known as the bow wave. But here is the problem with bow waves. The bigger the wave, the more energy it takes to push the ship forward. It's exactly like trying to sprint through waist-deep water. The water pushes back. For centuries, shipbuilders tried to solve this problem by making the front of their ships as sharp as a knife, hoping to gracefully slice through the ocean. But as steel ships got bigger, heavier, and faster in the early 20th century, a sharp front just wasn't cutting it anymore. The waves were too big, and the fuel costs were too high. They needed a radically different approach. Enter David W. Taylor, a brilliant American naval architect working in the early 1900s. Taylor was obsessed with making ships faster and more efficient. He built a massive testing pool and started dragging different wooden ship models through the water, meticulously measuring their drag. During these tests, he made a completely counterintuitive discovery. He found that by making the bottom of the hull rounded and bulky, sticking out ahead of the ship like a battering ram, the ship actually moved with less resistance. To traditional shipbuilders, this was crazy. Why would a fat, blunt nose make a ship faster? Despite the skepticism, Taylor's weird design was applied to an American battleship, the USS Delaware, in 1909. The results were remarkable. The ship was remarkably faster and far more fuel efficient than anyone expected. But how did a blunt nose defeat the mighty ocean? Today, this weird underwater nose is called a bulbous bow, and the secret to its success is pure physics. It relies on a beautiful concept called destructive interference. Here's how it works. When that giant bulb pushes through the water, it actually creates its very own wave just ahead of the main ship. Because of the bulb's precise engineered shape, the lowest point, or the trough of the bulb's wave, perfectly lines up with the highest peak of the ship's natural bow wave. When these two opposing waves crash into each other, they cancel each other out. The giant wall of water is simply flattened. By literally erasing its own wave, the ship glides forward with incredibly low resistance. When traveling at cruising speed, this bizarre nose reduces a ship's fuel consumption by up to 15%. On a global scale, that saves the shipping industry billions of dollars every year and drastically cuts down on carbon emissions. So, the next time you see a photograph of a giant ship, look down at the waterline for that weird, swollen nose. It is a perfect reminder that sometimes the most unexpected and bizarre ideas end up quietly changing the world. Thank you for watching Simple Things Surprising Histories. If you enjoyed this journey into the hidden designs all around us, please hit that like button, share this video with a curious friend, and subscribe to the channel for more. See you next time.